For nearly 2 decades, Airbus held a comfortable advantage in the long-haul twin-engine market with the A350-1000. It was efficient, modern, and reliable, and became the preferred aircraft for airlines operating long-distance routes across global hubs. But today, the balance of power in long-haul aviation is shifting. A new aircraft has entered commercial service, and it brings something Airbus cannot currently match. This is the Boeing 777X, the world's largest and most advanced twin-engine jetliner, built for capacity, efficiency, and performance at a level unseen in any previous wide-body aircraft. More than 622 aircraft have already been ordered by airlines around the world, signaling how significant this aircraft is for the future of aviation. For the first time in years, Boeing has produced a jet that redefines what a twin-engine aircraft can be. The question is no longer whether the 777X will compete. The real question is how quickly it will dominate its segment. The Boeing 777 family first took flight in the 1990s and quickly became one of the most successful wide-body aircraft programs in aviation history. Airlines trusted it for its long-range reliability, fuel efficiency, and ability to carry more passengers than any other twin-engine jet of its era. But global travel has evolved. Mega airports like Dubai, Singapore, Doha, London, and New York have grown into massive hubs. Airlines now need aircraft with higher payload capacity, longer range, and lower fuel burn to run these extremely profitable routes. It was this shift in demand that led Boeing to launch the 777X program in 2013. The new generation includes 2 variants, the ultra-long, range 777-8 and the high-capacity 777-9. The 777-9 forms the majority of orders and seats roughly 426 passengers. This is important because its closest rival, the Airbus A320-1000, seats approximately 350 passengers. That is a 76-passenger difference, which directly translates into millions of dollars of additional revenue per year per aircraft. On highly manned routes like Dubai to London, Doha to New York, or Singapore to Sydney, airlines can fill these extra seats with ease. But the passenger count is only half the story. The 777X has a significantly wider fuselage than the A350-1000, giving it a major advantage in belly cargo. Airlines rely heavily on freight revenue, especially on long-haul routes where cargo demand is consistently strong. The 777X can carry more cargo than any twin-engine aircraft currently flying, making it exceptionally profitable for airlines operating between major global hubs. This mixed-use capability, carrying both a high number of passengers and a large volume of cargo, is one of the 777X's biggest selling points. The A350-1000, optimized more for pure passenger efficiency, simply cannot match this level of scalability without a full redesign. Perhaps the most revolutionary feature of the 777X is its wing. The wingspan of the aircraft extends to 235 feet and 5 inches, 23 feet longer than the previous 777 generation. Longer wings reduce drag and allow the aircraft to generate more lift using less power. According to Mark Drella, an MIT aeronautics professor, the longer the wingspan, the less power needed to produce the same lift. In practice, this results in roughly a 10% reduction in fuel burn compared to competing wide-body aircraft. However, longer wings introduce a problem. Airports categorize gates based on wingspan. Aircraft up to 213 feet fall into Category Code E. Anything above that becomes Code F, which includes giants like the Airbus A320. Code F gates are limited, and airlines do not want restrictions on where their aircraft can operate. To overcome this, Boeing introduced a technological innovation never before seen in commercial aviation: folding wingtips. During flight, the 777X wings are fully extended for maximum aerodynamic efficiency. On the ground, the tips fold upward, reducing the wingspan to 212 feet and 9 inches, small enough to fit into normal Code E airport gates. The folding process takes about 20 seconds and is powered by an advanced hydraulic actuator system. Once extended, the wingtips lock into place with electrical locking mechanisms, and the aircraft physically cannot take off unless the tips are fully extended and secured. After landing, when the aircraft slows below 50 knots, the wingtips automatically fold for taxiing. This system required entirely new certification rules from the FAA, which had never evaluated anything like it before. Engineers had to prove the wingtips could withstand extreme crosswinds, turbulence, and mechanical failures. In January 2020, during the first flight test, observers watched closely as the aircraft landed, and the wingtips folded exactly as designed. It was a historic moment, the first time any commercial jetliner used folding wings. The wing itself uses advanced composite materials developed from the Boeing 787 Dreamliner program. Boeing built a dedicated $1 billion automated factory to manufacture the 777X wings, entirely in-house, a first in the company's history. The wing area grew significantly compared to previous 777 generations, and the aspect ratio increased from 9:1 to 10:1. These improvements create a wing that is lighter, stronger, and far more efficient. This combination of composite design and folding wingtips gives the 777X one of the most aerodynamically advanced wings ever fitted to a commercial jet. Powering the aircraft are the G9X engines, the largest commercial turbofan engines ever built. Each engine measures about 11 feet in diameter and uses only 16 fan blades made from advanced carbon fiber composites. The G9X is designed for maximum airflow, reduced fuel burn, and lower emissions. New materials such as ceramic matrix composites allow the engine to run hotter and more efficiently than previous generations. The G9X's massive size and efficiency, combined with the 777X wing, allow the aircraft to carry its high passenger load and large cargo volume while maintaining impressive fuel efficiency. Inside the cabin, the 777X offers an upgraded experience inspired by the Boeing 787. The cabin is wider than previous 777s thanks to thinner, more advanced wall materials. This allows airlines to configure 10 abreast seating with 80-inch wide seats, something passengers will appreciate on long-haul flights. The windows are larger, the cabin humidity is improved, and the pressurization levels are more comfortable. Noise levels have been reduced, and overhead storage has been redesigned for convenience. These improvements give airlines greater flexibility in designing premium cabins or high-density configurations depending on their market strategy. The 777X program has faced challenges, including delays caused by supply chain disruptions, regulatory changes, and the pandemic. Development costs have exceeded $5 billion, and deliveries have been pushed back to 2027. But despite the delays, airlines continue to show confidence in the aircraft. Emirates, Qatar Airways, Lufthansa, Etihad, Cathay Pacific, and British Airways remain major customers. Emirates alone holds nearly 270 orders, making it by far the largest 777X customer in the world. For these airlines, the 777X is not just an upgrade, it is central to their long-term fleet strategy. Airbus, meanwhile, faces a strategic limitation. The A350-1000 is an excellent aircraft, but it cannot be scaled further without a redesigned fuselage, new wings, and more powerful engines. Developing such an aircraft would require starting a new program, something Airbus has not announced. As it stands, Airbus has no direct competitor to the 777X in the high-capacity twin-engine market. This gives Boeing a rare advantage, especially as global travel continues to grow. Long-haul travel is trending toward large mega-hub operations. Airports like Dubai, Doha, Singapore, Istanbul, London, and New York thrive on connecting massive passenger flows. On these routes, airlines need aircraft with high seating capacity, strong cargo performance, and low fuel burn. The 777X is built precisely for this environment. It maximizes revenue potential while minimizing operating costs. It carries more passengers and cargo than any other twin-engine jet, while offering aerodynamic and engine efficiency that make it competitive in fuel consumption. The 777X also represents a symbolic shift in aviation innovation. When the jet touched down in Seattle after its maiden flight and the wingtips folded upward on the runway, it signaled a new era. Folding wings were once exclusive to military jets operating on aircraft carriers. Seeing them on a massive commercial airliner carrying more than 400 passengers was revolutionary. No other manufacturer, not Airbus, not Comac, not Embraer, has brought folding wings close to commercial certification. Boeing became the first to turn this concept into a practical, approved, and market-ready system. As global travel continues to evolve, the 777X is positioned to shape the next era of long-haul aviation. Its combination of capacity, efficiency, cargo capability, cabin comfort, and advanced aerodynamics makes it a unique asset for airlines. It is not simply an updated 777. It is a technological milestone. It represents the next phase of high-capacity commercial flight. And as airlines continue to consolidate traffic into mega hubs, the 777X stands to become the backbone of long-haul operations for decades. This is the aircraft that will redefine long-distance travel. This is the aircraft that will reshape airline economics. This is the aircraft that pushes commercial aviation into a new era. The Boeing 777X is more than a successor. It is a statement of what the future of aviation will look like.